Hi everybody. In this video, we will talk about resonance structures, the resonance structures of dot diagrams. So we have learned dot diagrams of compounds and polyatomic ions, but sometimes, there are some compounds, or I should say molecules, that have single bond and double bond. And if you have a single bond and double bond, hold on, let me see where my pen is. When you have both single bond and double bond, there is a possibility that you can have multiple Lewis dot diagrams. So, for example, you have nitrate, a polyatomic ion. Usually, this happens in ions or even regular compounds as well. It is possible, but it's mostly ions that it has multiple oxidation, multiple Lewis dot diagrams. So nitrogen has 5 valence electrons times 1, 5, and oxygen has 16 times 3, 6 times 3 is 18. And then there is add 1. So it is what? 14, and then 24. So there are 12 pairs. Okay. So once you have 12 pairs, the way we do is uh, we take nitrogen in the center, and you have oxygen, oxygen, and oxygen, and then you have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs. So you see that there are 12 pairs. I used all 12 pairs, and what happened is that this oxygen does not have 8 yet. Look, I see 8 here, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, but this oxygen does not have 8. So what happens is that chlorine, nitrogen will say that I'm going to use my lone pair to make a double bond. So the actual dot diagram of actual dot diagram of nitrogen is going to look like this. You have a double bond with this oxygen, okay, a single bond with this oxygen, and a single bond with this oxygen. What happens is these electrons are free to move. Okay, these electrons, they are constantly moving. So it is possible that this double bond is with this oxygen, it's single bond with this oxygen. So, but whatever happens, has a double bond will take 4 electrons. So the total will stay 8, 2, 4, 6, 8, 2, 4, 6, 8 for nitrogen, 2, 4, 6, 8. Okay, and it is also possible that the double bond goes to the bottom oxygen, and you have this one like this. So you see that it is possible that those electrons are revolving. So it is possible to have this dot diagram of nitrate, this dot diagram of nitrate, or this dot diagram of nitrate. So when any ion that has multiple right, correct, these are all correct or accurate. When you have multiple accurate dot diagrams or structures, Lewis structures, we call them resonance structures. Okay, they have the same formula, but the only thing is that the electrons are revolving around. So it can be with any of these. So all of these are the resonance structures of nitrate. So I should put them in the parentheses. Okay, it goes in the parentheses. These are all correct structures of Lewis dot diagrams of nitrate. So let's do another one with carbon. Carbon has 4 valence electrons, oxygen is 6, so it's times 3 is 18, 4 and 2, 12 pairs again. So carbon 1, 2 and 3 pairs. So maybe I should do it in a shape. Which shape should it be? It should be the trigonal planar. So carbon will go this, this, and this way. And then you have, so maybe I'm going to make a double bond here. So this is how it is. Now this double bond can go with this oxygen, and these can go single bond. That's all you're doing. You're just rotating the double bond. The double bond is rotating among all between between all atoms. Now these atoms don't change, they don't move. It's only the electrons that are moving. And all of these are the resonance structures of carbonate. So this is one, this is two, okay, and then there is another one. You have a double bond on this side and single bond on this side. So there are three resonance structures of carbonate. These are all carbonates, okay, and these are all accurate. It is okay to do any one of them because those electrons are constantly moving between the atoms. As I said, atoms don't change their position, it's only the electrons that change, and all three of them are called resonance structures. So the total formula doesn't change, but the structures can change. So that's all on resonance structures. Thank you.